Yes, class. So, electromagnetic induction. The first topic that arises is magnetic flux. So, we have already discussed electric flux. So, everything is similar to electric flux. It's just that the presence of magnetic field differs electric flux and magnetic flux. Now, magnetic flux means number of magnetic field lines that are crossing area perpendicularly. All right, number of magnetic field lines that are crossing area normally. So if you see there are three magnetic field lines, so you can directly say the magnetic flux is three. But see class, every time counting the magnetic lines is very difficult, right? Counting the magnetic field lines is difficult. So we have to have a proper mathematical formula for the same. So formula for magnetic flux, this is the dot product of magnetic field and the surface area. So this is also a very easy topic, very similar to electric flux. When you have Faraday's experiment, from Faraday's experiment, you mainly have to remember Faraday's laws of EMI. So what is the first law of Faraday? Faraday's first law states that whenever magnetic flux linked with the coil changes, EMF is induced, which is directly proportional to rate of change of magnetic flux. Means there's a change in magnetic flux, so rate of change of magnetic flux occurs. So this EMF that is developed, EMF is directly proportional to this rate of change of magnetic flux. What is meaning of d phi? D phi means final magnetic flux minus initial magnetic flux, whatever is the change that has occurred in the magnetic flux. So EMF is directly proportional to d phi over dt. Now, one more thing, second point in this occurs is this negative sign. First law of Faraday's EMI says that EMF exists. Whenever current changes, there is induced EMF. Whenever magnetic flux changes, there is induced EMF. Second point of Faraday's law is that EMF is directly proportional to rate of change of magnetic flux. But we see a negative sign as well. So this negative sign mainly states your Lenz's law. This says that whatever is the direction of the induced current or induced EMF, morely it's for induced current, the direction of induced current is such that will oppose the cause that produces it. So what is the cause of EMF? This was change in magnetic flux. So current will be opposing the change in magnetic flux. So if somewhere magnetic flux is increasing, the induced current will set its direction in such a manner to decrease the flux. That is what is meant by Lenz's law. Then these two relations are used for current. You write minus d phi over dt with multiplied by 1 by r, that is resistance if you have to find out current. If you have to find out charge, that is flux divided by resistance. So the derivations, small one-liner derivations are there. It can be asked in your 2-marker questions. Fine, even in your 1-marker questions, MCQs that arise, these options can be put up. All right. Then Lenz's law I have discussed, the direction of induced current is such that it opposes the cause that produces it. And what is the cause? That is change in magnetic flux. So it will oppose the cause directly. That is change in magnetic flux. And Lenz's law is in accordance with law of conservation of energy. This also can be asked to you in your MCQs, 1-marker question section A. Fine. Also, you have to find out the directions also. In your EMI, this is especially asked in the MCQs. All the options will be given north, south, depending upon which is the cause. For example, if north pole polarity is approaching, so the cause is approaching north pole. So what is your aim now? Aim of the, not your aim of induced current is to repel the north pole because it is coming. It is approaching. So best way to is to repel it. So how can you repel it? By developing this same polarity. So this is how you can oppose all the causes that are producing it. Fine. Now, this was a very good example that we discussed in the class. All of you have the link of this, right? So do keep on seeing these notes back. I think all of you have written it in your notes already. So induced current was what? In induced current, see, if magnetic flux is increasing, induced current will try to set its direction in such a manner that magnetic flux decreases. So how can you decrease magnetic flux? For example, in the first case, magnetic flux is increasing because this loop is moving into the magnetic field lines. So what will you do? How will you increase the magnetic field? how will you decrease the magnetic flux? You can decrease the magnetic flux by decreasing the magnetic field. So if both the directions of magnetic fields are in opposite direction, they'll cancel out each other, or the result will be the difference of them. So you will have to arrange the direction in such a manner that the generated or induced magnetic field is in opposite direction to that of the original magnetic field. So original magnetic field is inside, so we'll take it as outside. So when you put your thumb outside, curvature of fingers become clockwise, become anti-clockwise. Same way, when it is moving out, flux and magnetic field lines are decreasing. So induced current is set in a manner to increase it. So how can you increase it? When the net magnetic flux in magnetic fields increases, that is, both are in the same direction, then only it will get added according to the laws of vector addition. So how can you add it? So you keep your thumb in the direction of it, take the curvature of fingers, you will notice it is clockwise this time. Likewise, you have all the rest of the questions. Then a very important concept is of motional EMF in class. Motional EMF, this derivation is given a lot in your exam from your derivation points. No, from every chapter you do not have the derivations coming, but from your units you have certain number of fixed derivation. Like from your magnetic, some fixed derivations are there. From your electrostatic, some derivations are there which have to come. Like let's say from electrostatics, one derivation has to come. So it can be any of it. It can be derivation of a parallel plate capacitors formula or any other formula like this. These are fixed. So from EMI, motional EMF is one of the very important topics, and the derivation is very easy. You at the end get BLV. And apart from derivation also, this motional EMF is used in calculations as well. Then you here have voltage. So from voltage, that is EMF, you can derive out so many things. You can get current if you divide voltage by resistance. If you put in the value of BIL, that is force for a conductor, this will be equal to B square L square V by R. And power is force into velocity. So whatever formula for force you have, you multiply it by velocity, you get B square L square V square by R. So BLV by R, B square L square V by R, B square L square V square by R. Class, more than the formula for this, derivation can be asked. Derivation as in, first you have to derive motional EMF and then put it here and see what is the final value you're getting it. Then force is, just a second. So similarly, you have to get the EMF value. Again, you have to derive it properly. Show the working of the derivation and then put it in this formula so as to show it if it's in the derivation. Otherwise, if it's a proper question, then you can use these formulas. That's why I have mentioned it separately so that you can remember this as well. All right. Eddy current is not a part of your syllabus. You don't have to do eddy current. Last topic from EMI is induction. So you have self-induction and mutual induction. So self-induction is when the EMF, which you call as back EMF or the induced EMF, occurs in the same coil in which the magnetic flux increases or decreases. If in one coil magnetic flux increases or decreases and EMF is induced in another coil, you call it as mutual induction. Formula is almost same for both of it. Phi is equal to Li for self-induction, where L is your coefficient of self-induction, or you say self-inductance. Phi is magnetic flux and I is the current in the coil. So E is equal to minus L di over dt. And this is the formula you put it for inductance. Mu naught N square A is equal to mu naught N square A by L. Class, this induction completely is a very important topic from EMI, as the name itself of the chapter suggests the same, electromagnetic induction. So induction is the most important topic from the entire lesson. And this is a very small lesson. You just have 3 topics. So learn each topic properly. Do not leave anything because questions from EMI are very easy. Formula based or derivation, simple derivation. Like some tricks or modifications can be made in electrostatics. They can be made in AC also. But from EMI, no modification can be done. So it's better if you learn every topic simply and properly. And it's not even in so much detail. So similarly, you have primary coil in which the magnetic flux is changing, and in another coil the EMF is getting induced. EMF for the induced current, you can say. So phi is equal to MI There it was Li, that was self-inductance coefficient. Here you have Mi, that is coefficient of mutual inductance or mutual inductance, simply mutual inductance. Henry is the SI unit for both of them. Then for solenoid, you should remember the all those who will get their answers, share your answers in the chat column. Fine, try to solve all these questions. These are from your previous years only.
Ma'am, what is written after induced EMF?
Volt. 11 volt. This, no? This is 11 volt. Yes, class, I haven't received any answer. This was a very direct question. See, what will be the radius of coil if diameter is 0.02? It will be 0.02 divided by 2. That becomes 0.01 meters, right? Now see, what is the magnetic field initially? It is given as 6,000 Tesla. Finally, your magnetic field becomes 1,000 Tesla, right? Now what else? Time is given to you as 4 seconds and EMF is given to you as 11 volt. This much of information is provided to you. You have to find out number of turns. Look here, class. What is EMF? This is minus N d phi over dt. And how do you write phi? Phi is written as area multiplied by change in the magnetic field. So just place it here instead of it. So EMF will become N pi 2 minus pi 1 by T, or you can write this directly, that is N into A B2 minus B1 divided by T. Fine, is N pi R square B2 minus B1 by T. Now from here, this is equal to EMF. This is unknown. The rest of the quantities are known. So what will be N? This will actually be equal to EMF is 11 is equal to N into pi 22 by 7. Radius is 0.01 whole square. This is my 6,000 minus 4,000, right? This is 6,000 minus 1,000 divided by 4 seconds. So number of turns will become, this will go 7 into 11 into this 4 divided by 22. This becomes 0.01 whole square into 5,000. So your answer will come out to be 28 exactly. Please check your answers, match your answers. This was a direct questions and questions of these will come. This was from your CBSE previous year only. See, only I think Sumaira has answered. Sumaira, please try once again. Some error is there in your answer still. See, how will you get EMF? EMF is d phi over dt, right? So, what will you get on differentiating this? First, tell me EMF's value. See, 5t cube plus 4t square plus 2t minus 5. You are differentiating this d over dt. So you get 5, then this becomes 3t square plus 4 is there. This will become 2t. From here, you only have 2 and this will be 0. So what do you get? 15t square plus 8t plus 2. Now put the value of time as 2 seconds. So 15 into 2 square plus 8 into 2 plus 2. So EMF will become 15 into 4 plus 8 into 2 plus 2. So this will become 60 plus 16 plus 2. So 8 and that will become 78. 78 volt is EMF. If you have the value of EMF, you have resistance. How much resistance was given? 5 ohm. So current will become 78 divided by 5. That will be how much? 3 is 15. No, 5, 6. So 5, 5, 25.6 ampere. This much should be the answer. So only Samaira has given the correct answer. What about others? Why you people are not trying? Anushka, Sakina, Alan. Only Samaira is trying. So Samaira, your answer is right. See here, what is the change in the time that you have? dt is given as 0.5 seconds. Right. So d phi is given 8 into 10 to the power minus 4 Webers. So EMF will be what? EMF will be d phi over dt. D phi is 8 into 10 to the power minus 4 divided by 0.5. So it will be double of it. 16 into 10 to the power minus 4. Or you can write it as 1.6 into 10 to the power minus 3. So see, velocity V, if you say this is attained by the conductor as it falls through the height of 10 meters, so that velocity it is given by the kinematic equation V square is equal to U square plus 2AS. Now here acceleration is the gravitational acceleration due to gravity. So this equation will become V square is equal to U square plus 2GS. So what is the value of velocity? This V square will be equal to U square is 0. So it will become 2 into 9.8 into 10. So this will become 4 into 49. So V square was 4 into 49. So V will become 2 into 7. If you take the under root, so that is 14 meter per second. So motional EMF, which is equal to BLV, this is equal to 3 into 10 to the power minus 5 is the magnetic field, right? Length is 10, velocity is 14. So this becomes 4.2 into 10 to the power minus 4 volt. This is the answer. Note it down, text me done once completed.